This video is designed to help you figure out how to sort through an expression and simplify it that involves variables, exponents, and parentheses. So when we start with this problem, we should focus on the innermost parentheses according to PEMDAS, and therefore we should focus on that underlined section. And n to the third times n means n times n times n with another n attached, which means if we wrote the shorthand for that, it would be n to the fourth. So our goal is going to be to write things or visualize things in longhand and then write things in an in-between shorthand and then simplify from there. So we now have an exponent right there, that 2, which applies to the parentheses immediately below it, or to the left. N to the fourth is the only thing in that parentheses. So it says we are writing n to the fourth as a factor twice. And since we've now dealt with those parentheses and exponents, we can write out the rest of the line, what else is inside the brackets, and we recognize that it's n to the fourth times n to the fourth times n squared. Now we should simply be able to count n's in there. We could picture it longhand or even write it out longhand, but if we just let the exponents count for us, it tells us that we have 4, 8, 10 n's in a row, and so the shorthand is n to the 10th. Now we have an exponent of 4 applying to what's left in the bracket, which means the in-between shorthand or the intermediate shorthand, or simply interpreting what that exponent 4 is telling us, is n to the 10th written as a factor 4 times. Now this works as long as it's a nice lowish number like 4. If it was n to the 10th in brackets and 40 as the exponent, we'd be really annoyed writing it out. But as long as we can practice on lower exponent values, we can understand what's going on, and then the higher exponent values will automatically sort themselves out. If we wrote this longhand, we'd have a whole bunch of n's in a row. And how many would there be? There would be 10, 20, 30, 40 n's in a row, and therefore this is n to the 40th. In this second problem, we have a slight more complication because we have a fraction and we have multiple variables and numbers written together. I'm going to look at this carefully in the following way. If you thought of this problem as -1 times 2 times 2 times 2 times 3 times A times A times B, that would be the numerator if you wrote it out what you might call longhand. The denominator would be 2 times 3 times 3, writing the prime factorization of 18. There's 1 A and there are 5 B's. Be careful that you realize that only the b is being raised to the 5th power in this section. The b is to the 5th. A actually has an exponent of 1, even though it isn't written in the original problem. So once we've done this, we can pick up the red pen, which we use to cancel, and we can identify that anytime we cancel a 2 like that, we've simply removed 1 from the expression, since 2 over 2 is 1. We can cancel 2 3's. Again, we've removed a 1. Now we've dealt with the fraction, numerical portion of this fraction, which means obviously if we started with a negative on top and a positive on the bottom, our answer will be negative. So we can just put the negative sign out in front. And we can say we have 4 remaining on the top, since that's 2 times 2, and 3 remaining on the bottom. That's the only factor of the numbers left on the bottom. And of course, 24 over 18 reduces to 4/3, so you can think of it that way. Deal with the numbers, deal with the A's, deal with the B's. So coming back, we can look at this and say one of the A's on the top will cancel with the A on the bottom, and therefore we have no A's left on the bottom. We're done canceling, and we have 1 A left on the top. We can write A or A to the first. Either is okay. And when we do the canceling with the B's, we recognize that the B on top will cancel with one of the B's on the bottom, leaving us with 4 b's remaining on the bottom. Be careful to write that as b to the 4th and not 4b. Remember, 4 b's multiplied by each other means b times b times b times b, which is written in shorthand as b to the 4th. Finally, we'll look at a very complicated problem that has a mixture of variables, exponents, parentheses, and numbers in it. So this problem, again, you can approach it simplifying gradually, and I'm going to make sure that I work on the top and the bottom separately until I'm ready to clean things up. So the top, I'm still going to leave it as 2an squared, and then I'm going to work inside the brackets. 2a is being raised to the 3rd power, so that means 2 times a times 2 times a times 2 times a, and then there's a remaining a times n squared, and that's all being cubed. So that's the numerator as our first step, and the denominator, of course, this exponent right here is telling us to simply write this expression as a factor twice. So let's do that. 2a to the 3rd n squared times 2a to the 3rd n squared. Of course, we could follow some exponent rules, but until you're really comfortable with what's going on, those can get you in trouble. So this 2 here is, of course, telling us to write that expression twice. So we'll simply do that. 2a(n) to the 6th times 2a(n) to the 6th. All right, now, our next step is to clean up the numerator as much as we can, and then clean up the denominator as much as we can, and move on from there. So the numerator, we still have to deal with what's going on in the brackets. I'm going to simplify that first. 2 times 2 times 2, which we can do because of commutative property. We can move this 2, and this 2 together, and all those 2's multiplied by each other gives you 8. And you could leave it as 2 to the 3rd if you wanted to, and then cancel later. On the other hand, we can simply write it this way. Now that I think about it, I'm going to write it as 2 to the 3rd, because if we look down at the bottom, there's a denominator, there's a bunch of 2's as well. So I'm going to think of that as 2 to the 3rd, and possibly that will save me some work. Then I'm going to count my a's, and there are 1, 2, 3, 4 a's, so that's a to the 4th, and there's an n squared. And this is going to be written 3 times, but I'm going to just write cubed right now, and we'll do it 3 times on the next line. So the denominator has 2 to the 4th, since there are 4 2's in there as factors. So 2 to the 4th. We'll count our a's. There's 3, 6, 7, 8 a's, so that means a to the 8th, and we'll simplify our n's. There's 2, 4, and 12 more is 16, so that's n to the 16th. If we can clean up our numerator, we can look at it as 2a(n) squared, and then it's going to be times this factor 3 times, so it's 2 cubed, a to the 4th, n squared, and I'm going to try to squeeze that in 2 more times. 2 cubed, a to the 4th, n squared, times 2 cubed, a to the 4th, n squared. Didn't do that very well, but there you go. That's a square. All over, remember, our denominator is 2 to the 4th, a to the 8th, n to the 16th. And now we can clean up that numerator. We can count all of our 2's. We have 1, 2, 3 more is 4, 3 more is 7, 3 more is 10. So we have 2 to the 10th. We'll count our a's. We have 1 a right there. We have 4 more. So that's 5, we have 4 more, that's 9, and 4 more is 13, so that's going to be a to the 13th. And if we count our n's, let's do that in blue, we have 2, 4, 6, 8 n's, giving us n to the 8th, all over 2 to the 4th, a to the 8th, n to the 16th. So from here, our problem looks exactly like the problem we had before, which is that we have some variables on the top and some numbers on the top. So if we cancel the 2's, if we deal with the 2's, if we simply deal with this, we have 10 2's on the top and 4 2's on the bottom, which means if we cancel, we should have 6 2's left on the top, so we'll call that 2 to the 6th. If we deal with the a's right here, we have 13 of them on the top and 8 of them on the bottom, so if we cancel, when we're done, we should have 5 a's left on the top. And if we're dealing with the n's and we look at those guys, we have 8 on the top and 16 on the bottom. So when we're done canceling, the ones on the bottom win, and there will be 8 of those left over. So it would be n to the 8th. And this would be the way to write it, unless you were asked to multiply out the 2's, in which case I believe that would be 64. In any case, that would be a final answer, or 2 to the 6th, let's see, 2 to the 5th is 32, so 2 to the 6th is 64. 64 a to the 5th over n to the 8th. And some teachers might want you to write this using negative exponents so that it's not as a fraction, in which case it's 64 a to the 5th n to the negative 8th. That's it. Hopefully that's helpful.